control it either way. That is beautiful. Okay, github.com. Today, we are going to talk about something incredibly cool and incredibly weird. It's called recursion. We have seen how to define functions, right? Now, we have seen that functions can call other functions, right? Well, what happens if a function calls itself? I call other functions, right? Nothing terribly bad happens, necessarily, right? It just calls itself, tries to calculate the answer, and returns the answer, right? And it gets substituted, normally. Does that idea make sense? So, what we need to make sure is that when we call the other function, we pass it different parameters. Because if not, we would end up calling ourselves over and over again. The standard example is factorial. 1, 2, 3, okay, I have a typo there. Or the dots are not being displayed. What is the factorial of a number? You remember from probability, from counting? Yeah. Somewhere in middle school? What is the factorial of a number?
Factorial of the number n into n minus 1.
Sorry?
So n is the number.
Factorial.
Then n into n minus 1 into n minus 2.
Okay, so we multiply, right?
Yeah.
N times n minus 1 times n minus 2 until we get to 1, right? Okay. Another way to write it, right, is n factorial equals n times n minus 1 factorial. Does that idea make sense? So we used the same thing to define itself, right? That works as long as you have some sort of stopping condition, right? Okay, 0 factorial is 1. So when you get to 0, right, you don't have to calculate the factorial. You already know it. Does that make sense? So in Java, what does this look like? Well, we can have a function called factorial, right? It's called factorial. It takes an int and it returns an int, right? And then it checks, and this is my paranoia, just in case they send me something negative, right? There are ways to extend factorial to negative numbers. I don't remember them. But just in case, I'm going to return 1, just so I can never get into an infinite recursion loop. So if n is less than or equal to 0, I return 1. I'm done. I know exactly how to calculate the factorial of 0. It is 1. Now, if it is not, then what am I going to return? I'm going to return n times the factorial of n minus 1, right? Isn't this cool? Factorial is a function, just like every other function we have been defining, right? Except that this guy is this same guy, right? Does that make sense? So what happens if I call factorial of 3, for example, right? If I call factorial of 3, it's going to come and try to evaluate this, right? N is 3. Is it less than or equal to 0? No. Then I'm going to return 3 times factorial of 2, right? It's going to try to calculate factorial of 2, right? So in order to do that, it's going to come and say, we can look at it as, it's going to calculate factorial of 2, which is 2, and then I multiply it times 3, and I return 6, right? That's what's going to happen. Now, how did it calculate factorial of 2? It went back and looked at this, right? And said, oh, it's less than or equal to 0. No, it is 2. So return 2 times factorial of 1, right? How does it calculate factorial of 1? Well, it comes back here and says, oh, is n less than or equal to 0? No, right? So I'm going to return 1 times factorial of 0. How does it calculate factorial of 0? Oh, it is 0, so I just return 1. So factorial of 1 is going to return 1, and factorial of 2 is going to return 2, and factorial of 3 is going to return 6. Does that idea make sense?
So it's gonna stuck in like loop. And when it will
It's not
until
a loop, but it is, yes.
It will keep on multiplying until it reaches 0.
It will keep evaluating the function, yes, until it
Until it
reaches
reaches 0. But we don't see it. So we won't see it. It's in the backend process.
There is no backend process. It's just how it happens, right? I mean, you call the function, and if you're outside the function, you don't terribly care how it's done. It just gets done. Does that idea make sense? So in this case, it just gets done. And that's it. Is this cool? Is this confusing as hell? Should be both, right? We will see a bunch of other stuff like loops and things like that, but mathematicians figured out that this is all you need. If you have recursion and if statements, you don't need loops or any other things. This is enough to compute everything we can compute. So here I have an example for how factorial of 4 is calculated. So let's go look at this thing. So we want to do them here. Yeah, why not? Create. Today is February 6th, right? So I'm going to name my class February 6th, just so I don't get confused. And first of all, I'm going to copy this code so we can play. Of course, we can't do that because we need to declare it static, right? Once we do that, continue sharing. Why the heck are you asking me? Of course I want to continue sharing. Want me to move the mouse here? I'll do it. Now I don't want to run main. I want to run Feb6. So that's going to print eventually
24.
4 times 3 times 2 times 1. Yes, 24. Yay! Can you guys see that stuff? It's being recorded in full screen.
What does it mean? Exit
Sorry?
code 0. Process finished with exit code 0.
In Unix and so in every other operating system after that, each program that runs returns an int to the environment so that you could script it, and 0 was success. So 0 is all good. So that what this is telling you, IntelliJ actually went and looked at that stuff and figured it out. Does this make sense? Let me try something. Minimize. Don't die. Just minimize yourself. What happened? Okay, this is still here. Okay. F is good. Let me try to change the size. Were you guys able to read the characters, the letters? Is it good enough for you guys? Yes? No? Yeah, okay. Let me see if I can change the size of this display. I cannot. Never mind. Let me see if in here I can, and I can view, make this bigger, something like that. No, that wouldn't really help us much. There is a make bigger or something like that. Code. No. Maybe this will make it just bigger in general. Ah, that works, right? I don't know. What happens when I do this? Yeah, beautiful, right? This is what we need. Like this is what we should be doing all the time. So let's define another thing. The power function. Actually, we need a base raised to an exponent, right? What does that mean? That's 3 to the 4th power, right?
So base is 3, power is exponential, that is 4.
How can we do this, right? How can you express what's the power function, right? Well, if you know how to, can you express it? The idea for recursion is try to figure out a simpler case, right? What's a simpler case than raising something to the 4th power?
Just keep multiplying the same, like number over.
Yeah, so what's the simplest, the slightly simpler case than raising something to the 4th power? Raising it to the?
Yes. Multiplied by.
Okay, imagine that you're teaching somebody, right? And they want to raise something to the 4th power, right? What's a slightly simpler task of the exact same kind?
Something, the same number, same multiplied 4 times.
That's the definition, right? That's the end result, right? What's a slightly simpler thing than multiplying something to the 4th power?
Raise it to the 3rd power.
Multiply, right? Raise it to the 3rd power, right? How can we express something to the 4th power in terms of something to the 3rd power?
That's what I was thinking.
The number multiplied by number raised to power minus 1.
Yes, right? So we want to do something like this. Return
2 to power
base times power of exponent minus 1. Does that make sense? You see the simpler case, right? This is what we're trying to do. Does that idea make sense? Would this work?
It will work. We need to put the exit condition.
Yes, right? Not quite, because we'll just keep going until we get to negative numbers, right? Oops, we need to put base again. Power has two things, so it's the same base, right? An exponent minus 1. We need the exit condition, right? What's our exit condition? In recursion, it's usually called the base case. What's our base case? The one that's so simple that we already know how to do it. If the exponent equals 0, then what's whatever to the 0 power? 1, right? So, do we need an else? Now, do we want to put an else?
Yes.
That's a different question. I normally tend to write them like this, but since somebody said yes, then we'll do it. Does this idea make sense? Yes? What other examples can we do? Let's use it to print
I have one question.
yes.
If someone gives arguments as 0 and exponent is very high number, 0, 1000 for example.
Yes.
It will do the computation 1000 times even though it's 0.
Yes.
So we can, to resolve that, we can put one more condition. If the base is 0, then it doesn't have to go inside.
We could do all those kinds of things. Yeah. Let's do 3 to the 4th power. Yeah, you could do more conditions for other special cases, right? 0, 1, right? Depending on what you're doing, it may or may not be useful, right? Imagine that you put something like if base equals 0, return 0, right? Is that what you were saying?
Yes. Return 1.
No.
0.
Who knows? Let me do 0. We just changed the behavior, right? What's 0 to the 0th power?
0.
I think in math it's undefined, but I don't remember. Those are the things that you need to go search Wikipedia or something like that and figure out.
0.
Well, you have two rules that conflict, right? You have one rule that says 0 to the whatever is 0. And you have another rule that says whatever to the 0th is 1. So which one wins?
You have to use the logarithm.
Whatever.
Log. The log is going to be 1, 0 to the power of 0.
I don't know. I'll believe you. It's one of those things that, right, the definitions conflict. So mathematicians end up saying, oh, it's more convenient for us to define it this way because it will make this other function work, right? It will make this rule is more important than this one. So they'll make one of them work. I can't remember what was the definition. I'll believe you. That is fun. Yeah, that's the kind of stuff that you go verify on Wikipedia, right, or in a math book. But is that worth it as an optimization? This is an aside and has nothing to do with recursion. Is that something that's worth doing as an optimization? Well, it's making every other one slower, right? It's making every other case slower because now I need one more if that's always going to return false, and I keep going, right? Does that idea make sense? Would it still make my code faster on average? Maybe, probably not. It depends on how many times do they call it with base being 0 versus base being something else, right? But in general, probably not. I would assume, but neither one makes sense. Did you look it up?
Yeah, I put on load. If you do it,
So yeah, mathematicians come up with something to make it work, right? It's like, oh, I want this to work, so. I don't know. Sorry. I don't know. My brain just exploded. I don't think there's any reasonable principle. They just decide this rule is more important. We want to keep it. And so by convention, they define it some way, right? Just like we define 0 factorial to be 1, right? As opposed to be 0 or something like that. It's just. We have power function. We sort of have a clue about recursion, right? So imagine that we want to use it now for printing. And we are going to print all the numbers down from until we reach 0. Does that make sense? Each one in a separate line. So if you pass it with 10, it's going to do 10, 9, 8, 7. Right? Make sense? What we want to achieve? So, how do we know that we are done? If we don't want to print 0, how do we know that we are done and we don't need to print anything else? That's our easy case. What's our easy case? Right? If we get to 0, right, or a negative number, what do we do in that case? Absolutely nothing, right? Just exit. So if from less than or equal to 0, return. We are done. Woohoo! Right? Now, if it's not, then what can we do? How can we make this easier? Right? If we're trying to print every number down from 10 down to 0, how do we make it easier? Right? What's slightly easier than printing from 10 down to 0? Printing from 9 down to 0, right? How can we get from, right, 9 down to 0? Or how can we do, we're asked to print 10, right, from 10 down. So what's the first thing that we need to do? Print the number, right? Right? And then what do we need to do? Print all the other stuff, right? Would it be cool if we had a function that prints all the other stuff? Right? We do. What's the name of that function? Print down from, right? Does this make sense? Might even work. We printed 3 to the 4th power, which is 81, and then 54321. Does this idea make sense? Yes? No? Maybe? Imagine that now we get 2 variables, right? So we don't stop at 0, but we end at 2. By the way, is this useful or confusing? Confusing? What would be a better name for from and to? Or are these good names?
It is good.
Yeah.
So in this, what would be what we need to change?
Less than 2.
And that's it, right? So now we can count down from 5 to 3. Because we need to do this.
Yes.
Undie. What did it do? Run that thingy, of course. Yeah. 5 and 4, right? And we don't include 3. Does this idea make sense? Now, get a pencil and a piece of paper or a computer and a keyboard. And let's do print up. Yes, this is a contact sport. We need to practice. We need to do them.
From is still greater than 2.
From is lower than 2, right? Continue. Right? nominate a volunteer to come. Do it. Sorry? Yeah. But actually, wait a minute or two. I see other people's too. We still trying. Don't type space.
If
That's cool. It's actually gonna work by chance. But it's gonna work. Actually, other than the fact that you're doing
55. Right.
change it to print ln instead of print on line 37.
37. Oh, yes.
Yeah. 5. Okay. Oh, it's actually, yeah, you have another error. What do we print? Look at outer print line.
You print from.
From line 37 again.
Here. Why?
2 is constant, right? The one that's changing is from.
Okay.
That's the one.
Oh, yes.
Cool. Thank you. Do you guys notice the other mistake? Is this code indented correctly?
No, it should be under, else portion should be under bracket.
Yes. This is what you actually typed, right? What are we missing to make it work like you intended? This, right? In this case, it didn't matter because we don't really need the else, right? Because the if returns. So the other stuff is also done. but it's a good idea to use braces. Thank you. Yeah, mine didn't have an else, but this is cool. Does this make sense? Are we starting to... What else can we do? Let's see if we have another cool example. Power, counting. Ooh. And then actually, yeah, let's go do that stuff, and we'll do characters in a string more next time. But let me do more stuff with power. There is a couple of things. One, and it's not terribly important for Java because they don't do it, but one possible problem with recursion is that you are consuming space on the stack, right? In order to implement this stuff, the machine, the computer architecture, right, and the compiler, the code that is generated, we invented a way to cheat and make memory allocation and deallocation super fast, right? By having a stack. When you call a function, the parameters get put into the stack. And when you get out of, you put the parameters into the stack, so you have every local variable, space for all the local variables gets put into the stack, right? Then when you get out of the function, all of that stuff just gets erased, right? So you just move your stack down. Does that idea make sense? That makes it super fast, this allocation and deallocation, right? When you see computer architecture, this will make a lot more sense. But your Java program has a finite stack. So if you end up doing way too much recursion, you could end up getting out of the stack. Does that idea make sense? There is an optimization that when you call the exact same function, right? When you're returning the exact same function without doing anything to it, right? You could just reuse the same stack frame that you have. Does that idea make sense? Just in general. Which means you don't need to blow up your stack. You never need to grow your stack. So there is a slightly different style of programming recursion that is more complicated. I don't like it. What I really like about recursion is that if your problem is recursive, right, the actual recursion is super easy, right? If your problem is not recursive, then, and in a way, what we are doing is slightly dumb, right? We will see in a couple of weeks how to do loops, and most of these problems are better solved with loops. But if your problem is recursive, this is super easy, right? I mean, this function is actually super easy. Once you understand recursion, this stuff is easy, right? With accumulators, it's not as easy. So what we can do, right, is add an extra argument to our power function, right? We're going to call it pow_accum. We have base, exponent, and this accumulator, right, which is the current value, right? So if the exponent is less than or equal to 0, we are going to return that current value. If not, we are going to return pow_accum, the same function, with base, exponent minus 1, and now in that accumulator, we are going to put current times base. Right? And so this current is going to keep growing. Does that make sense? It's called an accumulator because it accumulates, right? All the result. The interesting thing is that this now just returns the whatever the function returns. Doesn't do anything to it. In here, we need to get that number and then multiply it times something. Here, we don't need to multiply it times anything. Does that make sense? Other programming languages, not Java, optimize this so that your stack doesn't blow up. So in other programming languages, this is much more useful. I tend to not use this. Normally, you are not going to blow up your stack. Now, there is another one that is really cool. How long does it take to do this multiplication? This power, right? How long does it take to raise something to an exponent? This way, sorry? It depends on what we ask. That's good, right? It changes. It depends on what? Does it depend on the base?
It depends on the exponent.
Depends on the exponent, right? How many steps are we going to do? If the exponent is 10, how many multiplications are we going to do? The exponent is 20? 20, right? So we do about exponent steps, right? You will see in data structures, we call this order of growth, right? And we call this linear, right? As your exponent grows, the time this takes is going to grow linearly, right? Base is not terribly important. Does that idea make sense? If you're raising something to the power of 10 to the power of 20, this is perfectly good. If you're raising something to the power of 1,000,000, right? This is probably still perfectly good. But, right, you may want to do something faster, right? How can we do it faster? One thing that we can do, right, is what happens if you're trying to raise something to an even power? To raise something to the 10th power, right? What can you do? Instead of going to the 9th, right? You can raise that thing to the 5th power and then square it, right? Does that make sense? Yes? No? Maybe? So, okay, that works for even powers. What can we do if we have an odd power? Square and then multiply it one more time, right? Does that make sense? So, we can change this. Let me call it power log. So what we do is if exponent is 0, right, we return 1. That's still the same thing, right? Now, instead of this, right, what we are going to do is int half power equals power log base and where. What's our exponent going to be?
This is even
Okay, but if it's even, what are we going to do with it? Divided by 2, right? Well, so what we can do is do, because we need to multiply, so we need an if, right? If is even what do we return? Then I need to define it even. How do you know if a number is even? Does this make sense?
Didn't get.
We divide the exponent by 2, right? So if you have 5, you're going to get what? 2 divided by 2. 5 divided by 2 is 2, right? If you have 1,000, you're going to get 500, right? 500. If you have 1,000, you'll get 500, right? And then 250, and then, right? If you get something that is odd, if you get 11, right? When you divide it by 2, what do you get?
5.
You still get 5, right? But now what you need to return is, so if you have something to the 11th, right? You would raise that thing to the 5th power, right? And then return that times itself, so that raises it to the 10th power, times the base, so that would make it to the 11th power.
Okay, so suppose 2x to the power 11 is there, then it will reduce it to 5.
It will,
Then it will multiply it by the answer of 5. Will multiply it by the another answer of 5.
yes,
And then multiply by base. So
yes.
it will be like, okay.
Does that make sense? Let me do this. So we can see how it works, right? Uh, 2 to the 11th, right? What don't you like?
We will define second one.
Base exponent, right? F is good. It was. Right? It calls power log of 11, right? Which then calls power log of 5, right? And calculates it. How does power log of 5 works? Well, it calls power log of 2, which calls power log of 1, power log of 0, and then it goes back up. And we calculate the right thing, 2048, right? So if we have something like, say, 21, right? It took me 5 times, right? It took me 5 steps. If I do 21 instead of 11, how many steps is going to take me? Twice as many steps.
No.
Maybe? No. How many?
No. It will take one more extra step.
It will take just one extra
One
step, right? Is this cool or what?
So I'm getting this calculation. But what is difficulty with writing? Getting the calculation correctly.
Yes, no. How do you think this becomes a lot easier to write?
It's just more practice.
Yes! Just do a million each, right? Recursion is not always useful. In fact, you don't use it that much. But it is one of those things that good programmers understand recursion. So understanding recursion is going to help you a lot. There is not many cases where you need it, but when you need it, you need it. And so it's probably a good idea to work on this until you get it. And you're doomed, you have to do it because that's what will be covered on the test. But it's also a very good idea to do it because it's good. So more practice and more practice. let's see. Let's do one more example since we have time. How can we check whether a string contains a character? There's a method on the string class, but how can we do it, right? What's a string? It's a bunch of characters, right? So how can you check? I can, actually I can't check, but I can do, I can add an extra variable, right? Does it contain this character from here on? Does that make sense? So does it contain it from the 5th character on? Does it contain it from the 10th character on? Does that idea make sense? And that's going to allow me to do recursion. How do you know what's the easy answer? What's your base case? If a string has 5 characters, right? How do you know what's your easy case? If a string has 5 characters, right? A, B, C, D, E. Does it contain the character E from the 10th character on? No. Do you need to know what the string is?
Yeah. So S
No, you don't care, right? It's from, right? You just
from
need
S,
the, so what's an easy case? When you reach the end of the string, right? How would you know that in this formulation? The length, you compare it with what?
compare with string length.
Compare what with string length?
From
Yes, from, right? So if from is greater than or equal than the string length, right? What do we know?
greater than equal to just
Maybe just greater, right?
yeah.
Is that what you're saying? Well, if a string has 5 characters, right? What are the numbers of those characters?
Oh, you mean
0, 1, 2, 3, 4.
Okay.
So once you get to 5, you're done,
0, yeah.
right? Yes, we count starting from 0. Does that idea make sense? Now, what's our other easy case? Imagine that you ask me for the character number 3 of the string, right? What do I need to do? The string has more than 3 characters, right? What do I need to do to figure out whether it contains it at that spot? If s.length equals what?
Three.
Why? We have checked the length, right? So what do we need to compare now?
Length minus
The actual character, right?
C. Yeah, C equals to
The character at from, not from, the character number from on the string, right?
yeah.
How do we get a given character from a string? Char at, right? If they're equal, then what do I know? Does that make sense? Otherwise, what can I return? Well, I know that it's not here, but it may still be on the rest of the string, right? So it would be really cool if I have a function that tells me whether a character is on a string from starting a given character, right? But I do, right?
Depends. Yes, no.
And then
How much?
from
Plus
plus 1, right? Because I'm going towards the end of the string, right? I can do it minus 1, and then I would need to check here with 0 rather than length.
What is the S dot
This is calling a method on a string, same as s.length, right? S.length tells me the length of the string. S.char@at tells me the character at a given number. Does that make sense? So if I had abc.char@at of 2 would return what? C, because we start counting at 0. Does this idea make sense? So I could try contains Does this idea make sense? Normally, when we do this, we also write a wrapper function because they don't really want to know this, right? So we write it like this. So that my users can write it like this. Does that idea make sense?
Why did you put 3 characters, SC and 0?
Because I'm starting from 0. I'm calling this guy now.
Oh, that one.
Sometimes, if this confuses you, you can write it like this. But we know that Java overrides functions, right? You can have functions with the same name as long as you have different number of parameters. But if that makes it easier, that's perfectly okay.
I have other question. Why do you put from in a S dot
This is a number, right? Character number 0. So I'm going to check s.char@at of 0. Maybe my variable names are not. To me, this makes perfect sense, a variable name. I don't know if it does for you or if it confuses you more. Or both. Any other questions? No? This is cool. Then we will, yeah, I think that's good enough for today. And I'll see you guys on Wednesday when we'll do more recursion. We are planning for you guys and maybe for some of the online people a test 2 weeks from today. Right? Just to get you there.
Midterm, right?
Sorry?
Midterm?
Yes. Yes.
What format is the test going to be in? Is it going to be like the assignments?
Yes and no. Actually, I'm gonna add even more, but I give you actual midterms. This is exactly what it would look like because this is what I did last time, right? You are gonna be writing code,
In paper or?
but you're gonna be writing on paper.
So what, like here, if you make mistake, like we'll come to know through Java that, at least so that we are making mistake, how will come to know in paper?
You don't. You know it because you know everything. Here's the deal. I have done this kind of, if you guys want to try, we can try it again, right? I've done it on computers. It sucks a lot more on computers. Here's the deal, right? If you do it on paper and you miss a semicolon, what happens? The paper takes it, right? I'm not even gonna realize that you missed a semicolon, right? You get a good grade, right? You do it on the computer and you miss a semicolon, what happens? Computer yells at you, right? You need to take the time to fix it. So when I did this, you get an even more bimodal distribution. We tend to have bimodal distributions in computing, right? For the most part, you either get it or you don't get it, right, by the time of the test. And so if you get it, you're going to get 100 or 90. If you don't get it, you're going to get 40, right, or 50. But with that kind of these 70s, right, the people who get it but don't get the latest one, the last stuff, right, you kind of get everything, but you don't quite get the Persian, right, so you lose 20, 30 points. If you do it on the computer, most of those people would end up being 30 rather than 70. So we'll do it probably. Unless you guys terribly complain. We can do it on the computer.
Story seems like we should not complain.
It's when you do it on the computer, you end up having a lot more with how fast you can type and those kinds of things, as opposed to whether you know it or not. But you can actually go look at the sample tests and decide what do you want to do. Just one word of caution. I'm giving you an actual sample test, so depending on when the midterm happened and when did we have things in different semesters, I have either stopped the recursion or included the next week, which is loops. And so this semester we are stopping at recursion. So when you go look at those materials for the midterm, you may see stuff that includes loops. Just ignore those. Loops will not be in this midterm.